Questions on the homework assignment? And 2-1. Two, 1, and 2, 3.
Oh, 21? No, wait, never mind. You already answered all these.
Okay.
Never mind, I don't know.
All right, guys, what we're looking at today is more of the formulas. Some more of our formulas, our theorems, our properties with trigonometric functions. So this here, we have the sum and difference formulas. Sine of u plus v, when we add two angles together, sine of those two angles added together is the same as sine of u cosine of v plus cosine of u sine of v. Sine of u minus v is equal to sine of u cosine of v minus cosine of u sine of v. And we have the same for cosine and tangent, or we have formulas for all these here. Now, the reason that these are helpful is because, again, this is going back before we really had calculators that could calculate all these angles. We really just had a table, a set number of angles. And most of the time, the tables either went from 0 to 45 degrees or 0 to 90 degrees. So if we're looking for angles that weren't on the chart or included in our table, we'd have to use these sum or differences to get there. Because if it only went from 0 to 90 degrees and I need to find sine of 120 degrees, well, we could find sine of 90 plus 30 and be able to find out what the value of 120 is based off this here, or any angles in between. And this goes for degrees and radians. So our first one here, the first one we're looking at is cosine of pi over 4 minus pi over 3. Well, this is lining up with our difference formula, cosine of u minus v. And our cosine of u minus v is going to be cosine of u, cosine of v, plus sine of u, sine of v. That is, yeah, it's just the formula. Because in our case here, u is pi over 4. V is pi over 3. So all we have to do at this point here is take this part of the formula and replace u and v with their given values for this here. So we start off with cosine of u. So cosine of pi over 4 times cosine of v, which is our pi over 3, plus sine of u, pi over 4, times sine of pi over 3. Questions on this here so far? Now at this point here, we could use the unit circle to find these values because pi over 4 and pi over 3 are on the unit circle. And we're looking at the x value of the ordered pair. Well, our cosine of square, or pi over 4 is square root 2 over 2. Cosine of pi over 3 is 1/2. Sine of pi over 4 is square root 2 over 2. And sine of pi over 3 is square root 3 over 2. Now at this point here, we just need to calculate this out. So if we multiply our square root 2 over 2 and 1/2, 1 times the square root of 2 is going to be the square root of 2. 2 times 2 is 4 plus. We multiply these two here, so our square root of 2 times square root of 3 would be the square root of 6. And our 2 times 2 is 4. Questions on this here? Now, since they do have the same denominator, we can add these together. And really, when I say add them together, we just make them a single fraction because we'd be adding the square root of 2 and the square root of 6. Since they have the same denominator, just over 4. So square root of 2 plus square root of 6 over 4. Over 4 minus 5 over 3. Questions on this here? Same answer, they just have our radicals flipped. So that's the nice thing about the calculator is that they can do these, but questions on how we found the answer for this first part here? We're good with this here. Now it might be very tempting to want to say, well, couldn't we just subtract the two angles, cosine of pi over 4 minus cosine of pi over 3? Well, cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 3 is 1/2. So really, we'd be square root of 2 over 2 minus 1/2. Keep the order the same. So really, we're just saying that we have the square root of 2 minus 1 over 2. And this is not the same value. It does give us different answers for this here. Questions on this first part here? Let's look at the next one. Sine of 135 degrees plus 35 degrees. So we have our sum identity. Sine of u plus v is equal to sine of u cosine of v plus cosine of u sine of v. Where u in our case is 135 and v is 35. On the identity sheet, I used alpha and beta, but that's still the same thing for u and v. It's just those are representing our angles. So at this point here, we're going to plug it in. So we'll say sine of 135 degrees times cosine of 35 degrees plus cosine of 135 degrees sine of 35. Questions on any of this so far? Now sine of 135 degrees is square root of 2 over 2. And we're multiplying it by cosine of, that needs to be 30 degrees. I keep forgetting to change that. Because otherwise it's not on the unit circle. That needs to be 30. I need to fix that. Which is square root of 3 over 2. That also needs to be 30. Plus cosine of 135 degrees is negative square root of 2 over 2. And sine of 30 degrees is 1/2. Questions on how we got to this here? Because Now at this point here, we just need to multiply these together. Really at this point, we could type it all in the calculator. It would do it for us. Our first one here, square root of 2 over 2 times square root of 3 over 2. Square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. Negative times a positive, so we would get a negative. Square root of 2 times 1 is square root of 2. 2 times 2 is 4. Telling us that our final answer is square root of 6 minus square root of 2 over 4. Questions on this here? And obviously, just like the last one, because that's supposed to also be 30, I do definitely need to go back to fix these. It's going to give us a different answer if we just added sine of 135 and sine of 30. It would not give us the exact value of sine of 165 degrees. Questions on this here? Now those aren't too bad, especially when they give us U and V, our two angles that are added or subtracted from each other. Now when they just give us sine of an angle, especially in radians, it might be hard to see what two angles we're either adding or subtracting to get pi over 12. Now our main few denominators for radians is either a value over 3, a value over 4, or a value over 6. And now at this point here, we need to add or subtract two of these together to get pi over 12. Well, because we can just start off with, say, pi over 3 plus pi over 4, which is 7 pi over 12. Okay, at least we do have 12. Pi over 3 plus pi over 6. Okay, well, that's not. Pi over 4 plus. No, nice. So unit circle, pi over 3, pi over 4, pi over 6. All of our units, even in the other ones, are 2 pi over 3, 3 pi over 4, 5 pi over 6. The denominator is always 2, or for radians is 3, 4, 6. So we're just messing with these to see, can I add any of these angles together, two of them together, to get pi over 12? Well, no, because I just used the first quadrant. Questions? So, pi over 12. I'm finding two angles. I'm trying to find two angles that add together to be pi over 12 or subtract from each other to be pi over 12. Well, the denominators are always in radians either 3, 4, 6 or 1 because we have pi and 0. But for the main ones, we have these here. Now, we do have two others because it is our over 2, which is really just our pi over 2 or 3 pi over 2. Because we can also try one of those there to see, can we add two of these angles together to get pi over 12? And most likely not. So the other option is subtraction. So we can say pi over 6 minus pi over 4. So that's almost actually, it just means we need to switch them. Pi over 4 minus pi over 6 does indeed give us pi over 12. So what we could say, and the reason that this is helpful, is that pi over 12 is the same as pi over 4 minus pi over 6. So if we want to find that value, we can split it up this way and use the fact that sine of u plus v is equal to sine of u cosine of v plus cosine of u sine of v. Which for us here, u is, or not, because this is minus, not plus. We should just change it to minus. And again, just like up to this point, I'm not going to make you memorize these. You have your reference sheet, I would be using it. Now, u for us is pi over 4. V is pi over 6. So again, for us here, we'd have sine of u, sine of pi over 4, times cosine of pi over 6, minus cosine of pi over 4, sine of pi over 6. Now, sine of pi over 4 on the unit circle is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. Minus cosine of pi over 4 is square root of 2 over 2. Sine of pi over 6 is 1/2. Questions on how we got this here? Now, there's different ways we can get to our pi over 12 because pi over 4 minus pi over 6 works. It's just finding one that does give us that value. Does that make sense? Because, let's look here. Yeah. I wonder, pi over 3 minus pi over 3 minus pi over 4 also gives us pi over 12. So we could use that one too. But no matter which ones we use, here, square root of 2 times square root of 3, square root of 6 over 2, minus, not 2, because 2 times 2 gives us 4. Will still get us to the square root of 6 minus square root of 2 over 4. Questions on this here? Yes. Well, here, 135 degrees, 30 degrees. Because most of the values are going to end up being very similar in nature. Because as we've noticed with our trigonometric angles, that really, if they're on the unit circle, there's only a set number that they can be. Same with these half angles, or these, yes. Yes. Because really what we're looking at here, pi over 12 is a half angle. As part of the half angle properties, we'll get there. Because half of pi over 6 is pi over 12. So we do have some of those similarities with this here. Now, even if, as we just saw, because we could have done, instead of pi over 4, as we also saw pi over 3 minus pi over 4, gave us pi over 12. And if I did this here, pi over 3, pi over 4, pi over 3, you don't have to rewrite this, pi over 4. Erase all this here. Well, sine of pi over 3 is square root 3 over 2. Cosine of pi over 4 is square root 2 over 2. Cosine of pi over 3 is 1/2. Sine of pi over 4 is square root 2 over 2. Square root of 3 over 2 times square root of 2 over 2 is square root of 6 over 4. 1/2 times square root of 2 over 2 is still square root of 2 over 4, which gets us to the same answer. So really, picking which one, it really doesn't matter. As long as those two angles either add or subtract to give us pi over 12. We'll get there. We just have to pick one that works. And I would pick the first one you come across. There's no real scientific way to get there, but like it only works this way. No, there's many ways to get there. Because that also means that, say, seven pi over 4 minus, let's see, 5 pi over 3 is also pi over 12. So I just picked two other angles on the unit circle. So we could have done it with 7 pi over 4 and 5 pi over 3, and we would have still gotten the same answer. Cosine of 7 pi over 12. I've actually already had this one put up there. Because pi over 4 plus pi over 3 will add together to give us pi over 12. So I feel like pi over 2 minus pi over 6. No. Nope. Because if we add these two together, we will get 7 pi over 12. Pi over 4 plus pi over 3 is 7 pi over 12. Questions on this here so far? Questions on anything we've done so far? Now, u in our case is pi over 4. V in our case is pi over 3. Questions on this here? Now, for the most part, the calculator can do these. Questions on these so far? Same exact answer. Find the exact value of sine of 75 degrees. Again, calculator can do this. If we're using the unit circle, we're trying to find two angles that add together to be 75 or subtract from each other to be 75. So two of the angles we can use are 45 and 30, because sine of 45 plus 30 will give us 75. Again, matching up to our sine of u, cosine of v plus sine of v, let's keep it the same. Cosine of u, sine of v. Now u in our case is 45, so we'll have sine of 45 times cosine of 30 plus cosine of 45 sine of 30 degrees. Now we can replace the value, so we'd have square root 2 over 2. Cosine of 30 degrees would be square root 3 over 2. Cosine of 45 is square root 2 over 2, and sine of 30 is 1/2, which would give us square root of 6 over 4 minus square root of 2 over 4. Questions on this here? All right. I think we've got the handle of this. It's just the exact same thing. We find our two angles to get us there. Now for these next few here, it's not actually asking us to find the value, because this here sine of 3 times cosine of 1.2 minus cosine of 3 sine of 1.2. All this is asking us to do is to simplify. We're not actually finding values. We're not finding what the exact value of this is. We just need to simplify it down into a single term, a single expression, in terms of sine, cosine, or tangent. So, well, sine times cosine minus cosine times sine. Well, this is matching up to our sine of u, cosine of v minus cosine of u, sine of v, which is our cosine. Sine of u minus v. This is just our difference formula for sine. And it's telling me that u is what? 3 and v is. So really what we have is sine of 3 minus 1.2, which is sine of . So this one here, we're not so much trying to find a specific angle, a specific value. We're just trying to condense it back down. They gave us the entire difference formula. We just had to figure out what it was to start with. Questions on this here? Sine of 2x, cosine of x, cosine of 2x, sine of x. Well, sine of u, cosine of e plus cosine of u. Some formula. This time u is 2x, v is x. So for this one here, all it's telling us is that it's reducing it to sine of 3x. Questions on this here? All right. This is the first one that we've actually had tangent. And again, we're going to line it up. Now, our tangent of alpha plus beta, we have tangent of alpha plus tangent of beta over 1 minus tangent of alpha, tangent of beta. But our subtraction, tangent, or tangent of u minus v. Tangent of u minus tangent of v over 1 plus tangent of u. This lines up more with our difference because we do have plus 1 plus on bottom and the two tangents are being subtracted. Now this does tell us that u is 1.1 and v is 4.6. Really telling us that we have tangent of 1.1 minus 4.6, which in simplified form would be negative 3.5. Questions on this here? All right. These here, sine of u plus v. Find the value from the given information. So they give us this here. They tell us cosine of v is equal to negative 12/13. And sine of u is 4/5. We want to find sine of u plus v. With any of this here, it's going to be helpful to set this triangle up, or set these triangles up on the coordinate plane. Because we have 0, our pi over 2, pi, 3 pi over 2. Angle V, V is between pi over 2 and pi. So we're over here in the second quadrant. U is between 0 and pi over 2. Over here in the first quadrant. U and our V. Well, we can go on and find V first. Now, cosine of V, cosine of this angle is negative 12/13, adjacent over the hypotenuse. Now, to find the missing side, we're just going to use Pythagorean's theorem. A squared plus our b squared is equal to, well, we don't have to use the 12/13. We can just use our sides of the triangle. Negative 12 is equal to 13 squared. Now, negative 12 squared is going to be 144. 13 squared is 169. At this point here, we can subtract 144 from both sides, telling me that a squared is equal to 25. And lastly, we'll take the square root of both sides, telling us a is 5. Now, we do have the plus or minus, but if we look at the triangle, when we put the 5 back in, it is on the y-axis, the positive y-axis, because it's going up, so it's going to be positive. So that finishes out that triangle there. U tells us sine of u is 4/5. Sine is opposite over the hypotenuse. And we can do the exact same thing to find A. And it is just 3, 4, 5. Because it will indeed tell us that the third side is 3. Positive, negative 3. And since the 3 is on the positive x-axis, it's going to be positive 3. Questions on how we set these two triangles up? Okay. I'm going to make a little bit of room. Sine of u plus v. Sine of u, cosine of v, plus cosine of u, sine of v. So this here is just straight from the formula. Now, out of all these, we did have some of these values to start with. Sine of u is 4/5. And they did give us cosine of v to start with, negative 12/13. Now, they didn't directly tell us cosine of u or sine of v, but I can use the triangle. Cosine of u is adjacent over the hypotenuse, so 3/5. Sine of v is opposite over the hypotenuse, so 5/13. Now, at this point here, we could plug this all into the calculator and let it do it for us. If we do this by hand, we had negative 48/65. And here 3 times 5 is 15. 5 times 13 again is 65. And negative 48 plus 15 is negative 33/65. And there are no like terms, so it doesn't reduce. We just have this here. Questions on this here? All right, we'll pick this up tomorrow.